Welcome, and this is Mrs. Edwards with the review and preview problems from the CCG book, numbers 8-71 to 8-77. Examine the shape below. Find the area and the perimeter of the shape. On graph paper, enlarge the figure so that the linear scale factor is 3. Find the area and the perimeter of the new shape. What ratio of the perimeter of both shapes? What is the ratio of the areas? So looking at our figure, when I calculate the area, if I look at all of my solid shapes first, I can tell how many x's I have. 4 plus 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 4 gives me 32 units. These are half of a box, so that would count as 33, and this would count as 34. So the area of my shape equals 34 units squared. To find the perimeter, I am going to add up all of my sides. So I have a length of 4 units, I have a length of 4 units, a length of 3, a length of 2, a length of 5, a length of 2. I can use my Pythagorean theorem to find my distance. So 4 and 4 would give me c squared. So 4 squared plus 4 squared equals c squared. 16 plus 16 gives me 32. When I take the square root of 32, it gives me approximately 5.66. So when I add up all of those units, I get approximately 25, if we round up, 0.7 units. So 25.7 units. On graph paper, if you enlarge your figure, by a factor of 3, and we're talking about our perimeter is talking about a one-dimensional increase. So we could take 25.7 and multiply that by 3 to get a new perimeter of approximately 77 units. However, our area is talking about our units squared. So if we have a scale factor of 3, our zoom factor essentially is 3 squared, which is 9. So if we take our original area of 34 and multiply it by 9, we would get a new area of approximately 306 units squared. What is the ratio of our perimeter of both shapes, and what is the ratio of our area? So if we take our perimeter and create a ratio, if we have 77 over 25.7, get a ratio of approximately 3. And when we take our area of our larger, which is 306, to our area of our smaller, which was 34, we get a ratio of approximately 9. 8-72. Sandip noticed that when he looked into a mirror that was lying on the ground 8 feet from him, he could see a clock on the wall. So we have our person. He is looking at a mirror that is laying on the ground that is 8 feet from him. He can see a clock on the wall. If Sandip's eyes are 64 inches off the ground, and if the mirror is 10 feet from the wall, how high above the floor is the clock? So when we draw the rest of our picture in, we need our clock on the wall. Our clock is 10 feet, or the wall is 10 feet from the mirror. And it wants us to know how high above the floor is the clock. So the first thing I notice is that my units are not the same. So I need to convert my feet to inches, which gives me approximately 96 inches. And 120 inches. So I now can create some triangles. We can set up a proportion. So if we look at the triangle on the left, 64, we have 64 over 96 is equal to x over 120. When we use inverse operations or cross multiply, we get 7,680 is equal to 96x. So x is equal to 80 inches, which we then could convert back into feet by dividing it by 12. And 80 divided by 12 would be approximately 6.67 feet. (8-73) Mr. Singer has a dining room table in the shape of a regular hexagon. While he loves this design, he has trouble finding tablecloths to cover it. He has decided to make his own tablecloth. In order for his tablecloth to drape over each edge, he will add a rectangular piece along each side of the regular hexagon as shown in the diagram below. Using the dimensions given in the diagram, find the total area of the cloth. So looking at my diagram, the first thing that comes to mind is I can divide this up and I can put both of these sides as 3 because the radius of my hexagon would be the same. I could then know that this dimension of my equilateral triangle so create my right triangle, and then I could solve for what. So 360 divided by 6 would give me a 60-degree angle. So if I know I'm working with a 60-degree angle, it does in fact prove that it's an equilateral triangle, and the length of my rectangle is 3. So if the height is 1, I know that the area of all of my rectangles would be 3 times 1, which equals 3, and then we want to multiply by 6 because we have 6 of them. So we need 18 units squared. We then can continue to find the height of our triangle. If we know our base is 3 and we know this whole angle is 60, half of it would be 30. My opposite side and my hypotenuse would be the sine. So the sine of 30 degrees equals my opposite side over my hypotenuse. 3 times the sine of 30 gives me 1.5. I want my adjacent side. So if I doubled 1.5, that also would verify that the base of my triangle is 3. But my adjacent side, I want to use cosine. So the cosine of 30 degrees equals my adjacent side over my hypotenuse. Use inverse operations. So 3 times the cosine of 30 is approximately 2.6. So if we take 3 times our height of our triangle of 2.6 divided by 2, I get the area of approximately 3.9. I have a total of 6 triangles because I have a 6-sided shape. So 3.9 times 6 gives me 23.4 units squared. So when we find the total area, we need to add 18 to 23.4, which would give us approximately 41.4 feet squared of fabric that he needs. 8-74 says, what is the probability that x squared plus 7x plus k is factorable? K is a number that is greater than 0 and less than 20, and it is an integer, so it is a number on our number line. So if we think back to Algebra 1, when we worked with our diamond problems, and we had two numbers, x and y, that added to equal 7x, so add to equal 7, and multiply to equal k, the numbers between 0 and 20 that add to equal 7 and that are both positive would be 0 plus 7, 1 plus 6, 2 plus 5, and 3 plus 4. So in order to get k, these two numbers must multiply together. So 0 times 7 would give us a k value of 0. 1 times 6 would give us a k value of 6. 2 times 5 would give us a k value of 10. And 3 times 4 would give us a k value of 12. So k would have to equal those because these are the only k values that would make it factorable. But then they asked, what is the probability of that? So in order to find the probability, there are a total of 21 integers from 0 to 20, including 0 and including 20, and there are 4 possible factors. So if we have 4 possible factors out of 21, the probability is approximately 19.05%. 8-75. Your teacher has offered your class extra credit. She has created 2 spinners shown below. Your class gets to spin only one of the spinners. The number that the spinner lands on is the number of extra credit points each member of the team will get. Study both spinners carefully. Assuming that each spinner is divided into equal portions, which spinner do you think the class should choose to spin and why? So looking at the spinner on the left, we earn 20 points of extra credit only 1/4 of the time. Looking at the spinner at the right, we would earn 10 points of extra credit half the time, and we would earn 5 points of extra credit half of the time. What if the spot? So question B says, what if the spot were labeled 100 instead of 20? Would that make any changes? So looking at these two options, back to question A, which spinner would make sense to choose? Well, looking at this spinner on the right, the chances of earning more extra credit points would add up faster than choosing the spinner on the left, because the probability of getting a 20 is only a 1 in 4th chance, and the spinner on the right would give us either 5 points or 10 points, and it's going to give us points regardless either time. If we change the 20 to a 100, would that make a difference? So looking at this, we would still have a 1 in 4th chance to hit the 100. So we would get 100 extra credit points again, 1/4 of the time. So our answers may actually vary on this. So we would have less odds to get 100 points, but 100 points are substantially more than 5 or 10 points. So the spinner on the left becomes way more attractive, but our answers could vary as to which spinner we would choose. 8-76. If the rectangles below have the same area, find x. Is there more than one answer? Show all of your work. So looking at this shape right here, it tells me that all of my sides are congruent. So I know that base times height equals area, and I know the base and the height of my rectangle on the right, and they told us that they were equal. So we can now solve for x. Don't forget, when we multiply a binomial times a binomial, we need to distribute. So we get 2x squared (20x, negative 3x, and negative 30). So 2x squared, 20 minus 3 is positive 17x minus 30. We could use our inverse operations, move everything to the left-hand side. We have it set equal to 0. So we could, in fact, factor in order to solve for x, or use the Pythagorean theorem, or the quadratic formula, So we know 2 is a, b is negative 17, c is 30, x equals negative b plus or minus the square root of b squared minus 4 times a times c. all over 2 times a. When we simplify this out, we get x is equal to 2.5. Oops, excuse me, 2.5 or 6. So there is 2 values that x could be. 8-77 is a multiple choice question. A cable 100 feet long is attached 70 feet up the side of a building. 100 feet is attached 70 feet up the side of the building. If it is pulled taut, meaning there is no slack, and staked to the ground as far away from the building as possible, approximate what angle the cable makes with the ground. So they want to know, what is this angle? If we are talking about a right angle, we can use right triangle trig. This right here is the side opposite. This is our hypotenuse. Sine uses opposite over hypotenuse. Remember, when we're looking for an angle, we use inverse trig functions. And when we type that in, we get approximately 44.43 degrees, which is letter B.